Alright, so this video we're going to look at finding the equation of the for our trig function given the graph. Alright, so looking at this graph, well, if we look here and we start at 0, okay, well, we know that the graph of the sine function looks like this, okay. Well, if you look at this graph, it looks similar to this, but it's flipped if we look at it from here to here. Okay, so this would be the graph of a sine function, but what makes it reflect about the x-axis? A negative in front of the sine function. Okay, so there's no horizontal shift, there's no vertical shift. Okay, so it's just going to be a regular sine function, and we would find the function just like we would if it looked like this. But the only difference is at the end we'll put the negative in front to make it reflect like this graph does. Now let me say this also, there's other ways that we can look at this too. You see, if we start, let's just say if we started here, look at this part, that's a sine function right there. So we could model the equation on this sine function with it having a horizontal shift of 1 unit. But we're not going to do that in this one. I have other examples uh, about that. So actually the first two examples, they're just regular. There's no shift. It's not reflected about the axis. That's examples 1 and 2. I'll have eight examples. Examples 3 and 4, that'll be reflected about the x-axis. One will be a sine function, one a cosine function. Examples 5 and 6, it will have a horizontal shift, and examples 7 and 8 will have a horizontal and vertical shift. So you can check those out also. All right, so let's go ahead and write down our function. So we know our function y is equal to a times sine of bx plus c plus d. Okay, that's the form of our function. Well, from here we can see that a is equal to 4, right? That's the smallest and largest value. But since it's reflected about the x-axis, a is negative 4. Okay, all right. And then we can see there's no horizontal shift, so c is equal to 0. And there's no vertical shift, so d is equal to 0. Okay, all right. So now we got to figure out what b is. Okay, well, we know that the period is equal to 2 pi over b. Okay, well, what's the period of this function? Well, the period, let's just write that down again. The period, which is 2 pi over b, well, what's the period? Well, the period is from 0 to 2. Okay, see, that's where it makes one complete cycle, and then it just keeps repeating. So the period, it's the largest value minus the smallest value, and so the period has a length of 2 units. Okay, so we replace the period with 2, so 2 is equal to 2 pi over b, and then if I solve for b, 2b is equal to 2 pi, so b is equal to pi. So there's b. So now that gives me my function. Okay, see, look at this. I have a, c, d, and b. And that's what I need, a, b, c, and d. So my function is y equals a, which is -4, times the sine of b, which is pi, so pi times x, plus c, which is 0, plus d, which is 0. So my function would be -4 sine of pi times x. And that would be the function that models this graph. And like I said, there's other ones you can get. We could have done cosine. We could have done a sine function that shifted horizontally 1 unit. Okay? So, you know, but, just go with the obvious one here. It starts at 0. It makes one complete cycle from 0 to 2. All right. So be sure to check out the other examples. I'm trying to hit every possible scenario that you'll come across. So thanks for watching. Give me a like, subscribe, and share.